Alright, this is section 1.2, basics of functions and their graphs. The first thing we're going to talk about is a relation, which is just going to be your set of ordered pairs. And the domain is the set of all the x coordinates. And we recall that the range is the set of all y coordinates within a given relation. And basically what we want to remember there is that each element in the domain corresponds to exactly one element in the range. Okay, so the next thing we're going to talk about is going to be function. And a function is a relation in which each element of the domain corresponds to exactly one element of the range. That's what we just said. So no x value can correspond to more than one y value. And we're going to look at a couple of examples now. So if we're given the relation in 3a, I'm going to give you a second to look at that, and you're just going to tell me yes it is a function or no it is not. So let's look at part A and part B. So yes, this is a function because every x value is different. And then we look at part B and we say no, this is not a function. In particular, the x value 6 has two different y values mapped to it. So this is not a function. Number 4 says determine whether each equation defines y as a function of x. So in this particular case, it may be helpful for you to solve for y in each of these, so then we could look at that and determine if we were to plug an x in, if we would get a unique value. Okay, so we see here when we solve this one for y that any value we plug in for x would give us a unique value for y. So we say yes, this is a function. But if we look in part B and we solve this for y, you're going to have this plus or minus right here, which means we're going to get 2, and this is not going to be a function. Okay, the next thing we're going to do is we're going to move to just function notation. And we do that a lot in transitioning from college algebra to pre-cal. It's basically we're going to write things in function notation quite often. So basically when we're used to doing y equals, y equals, y equals, we're now going to look at that as f of x equals, and they have the same meaning. So rewriting number 5 in function notation would simply just give us f of x is equal to that same equation. So I want you to become comfortable with rewriting equations of y equal format in function notation. And then in 6, you're going to evaluate a function. So if I give you f of x equals x squared minus 2x plus 7 and ask you to evaluate it at each of these values, then what would you get? So we're going to pause it and take a minute to do that. When you write this everywhere that there's an x, you want to put a parenthesis, and then we're evaluating when x is -5, so let's put -5 in there. And then you're going to evaluate this, and you will get, okay, and we get 42 there. We're going to look at the second one, which is this one right here, and that's going to be f evaluated at x plus 4. So everywhere there's an x in our original function, we want to put a parenthesis, and we might want to save a little more room this time because we have a bigger value to put in there. When I substitute x plus 4 into the function, this is what I get. Now we want to actually go out and simplify this. So off to the side, you will need to FOIL this out and then distribute this -2 to this parentheses, and then we want to add like terms. So with our scratch work, we came up here. This simplifies to our x squared plus 8x plus 16. And then we're going to get minus 2x, -2x, minus 8 plus 7, and all that simplifies to x squared plus 6x plus 15. And one more, we're going to evaluate f at negative x. Okay, so our last one is going to be evaluating at f of negative x. So negative x squared is just going to be positive x squared plus 2x plus 7. All right, moving on, graphs of functions. The graph of the following functions in the same rectangular coordinate system, we want to be able to fill out these table functions. So we want to solve for f of x means the same thing as y equals, remember? So we want to take this function, f of x, our first one, we're going to work with f of x first. And we want to plug in values for x and solve for y, essentially, and we're going to fill this table out. So our first one is f of 0. So I'm going to do this one first. F of 0. When x is 0, that means come over here and plug 0. And what is the square root of 0? 0. So we're going to put that in. Now these two make an ordered pair, actually. So this is just the ordered pair 0, 0, which if I wanted to go ahead and do that, let's come over here and jot that down. Now let's move to f evaluated at 1. What is the square root of 1? Just 1. Good. So that would give us the ordered pair 1, 1. Remember in graphing we go over to the right 1, up 1. F of 4 is next. Evaluate the function at 4. So what is the square root of 4? 2. So our ordered pair is 4, 2. We're here, and our last one. So evaluate f at 9, and that will give us the square root of 9, which is just going to be 3. So we have the ordered pair 9, 3, which is going to be off our page, or let's just say we're roughly here. And we would name this function our f of x function. Okay, so we're going to evaluate the g of x function now, and let's do g of 0. So that's going to be the square root of 0 minus 2. So what is the square root of 0? 0, and then negative 2 is just going to be negative 2. What's the ordered pair for this? When x was 0, y was negative 2. So let's go ahead and we'll plot these as we go. Evaluate g at 1, so that's the square root of 1. Square root of 1 is just 1, and then we subtract 2 and we get negative 1. So we'll put that in our table up here, and now we have the ordered pair when we let x equal 1, y was negative 1. So we're there. So evaluate g at 4 is next. So we have square root of 4 minus 2. That's just going to be the square root of 4 is equal to 2. And then when we subtract 2, we get 0. So it's the ordered pair 2, 0. And I think we have one more. So g of 9, square root of 9 minus 2. Square root of 9 is equal to 3. 3 minus 2 is 1. So we have the ordered pair 9, 1. Looking at the two functions, we can see that the same functions just shifted, g of x just shifted down 2 units, and you will learn more about that in transformations.